Hi, everyone, and good morning, good afternoon, or good evening, depending on where you are in the world today. We're excited you could join us for our inaugural episode of Pentester Confessions, True Stories from Security Experts. I'm Kim Wolf, Director of Marketing here at BugCrowd. And with over 20 years of cybersecurity and pen testing experience, I'm excited to introduce our host, Phil Wylie, who will be joined by security experts that are going to share their real-life experiences in the trenches, including best practices, techniques, and what organizations need to know about modern pen testing. And with that, I'm going to hand it over to Phil.
Hi, Kim, and hello to our listeners. Thanks for that warm introduction. As Kim said, I'm a red team lead and pen tester for a global consumer products company. I'm an adjunct instructor at Richland College and the founder of the Pwn School Project. And recently I took a ICS course before all the social isolation stuff came about, and I was fortunate to have taken an ICS class at the SANS ICS Summit in Orlando, Florida, and Don Weber was my instructor, and I thought he would be a great person to launch our first episode of Pentester Confessions. Welcome, Don. Could you tell the folks a little bit about yourself?
Thanks, Phil, and excuse me. It's a pleasure to be here, and thank you very much for having me on. Don Weber. I've been in computer security since 2002 when I graduated college. Right now, I'm specializing in doing security assessments and penetration testing within environments that have industrial control systems or operating technology environments. I teach the SANS ICS 410, which is the ICS SCADA Security Essentials, and also the class that you took, which is a hosted class via Control Things. It's called Assessing and Exploiting Control Systems, where we teach a little bit more about the penetration testing methodology, security assessment methodology, and really dive into the technologies, especially on the hardware side, where we talk about pulling components apart and how to get information so that you can leverage that within these types of environments.
Next slide. So ICS or industrial control systems has become very popular in recent years, although it's not a new technology. Don, could you tell me what industrial controls are and where is it used?
Well, industrial control systems are those devices that we say bridge the physical world and the digital world. We have networks, or we have these areas within our world where they're building things or they're distributing things. They're making chemicals, those types of things, and all of those processes that are automated have to be controlled some way. We need information from those things to help to manage the process, to keep the process safe, and to understand all the variances that are going on over time. So when we're talking about industrial control systems and the devices that are in there, we're talking about the things, the sensors that are providing that information, back to what we consider controllers, our program logic controllers, which are looking at that information and then making some type of decision based on its programming to that process, whether it's to increase the pressure or fill up a tank, or even modify the directions boxes are going on a conveyor belt. These are the sensors, or the PLCs, program logic controllers, will take information from those sensors and take action on an actuator, whether it's an engine or some other type of switch. And it's those devices that are being connected or have been connected to a company's network, and that information is being fed back to master servers, Windows-based, Linux-based master servers, so that it can store that information and make more advanced decisions on the process. And those are the devices that you are going to run into when you go into our industrial control systems. One of the things the reason why we talk about this so much more now is the fact that when these systems were being connected to our control networks, the control networks were also connected to our corporate networks. And that is a part of the problem. If something happens within our corporate network, if we have a malicious insider, or if an attacker gets in, and they may be able to, from their systems within the corporate network, interact with the endpoints, with the controllers, with the actual endpoints on the control network. And that's what we're trying to help people understand, help people protect. Does that answer your question?
Yes, it does, Don. Thanks for that explanation.
Excellent.
So how similar are some of the technologies used in that compared to IoT?
Well, embedded devices are, they are made up of the same type of components. So you're going to have microcontrollers, you're going to have memory components. Presumably, there's going to be some type of communication interface, whether it's serial or Ethernet or both. And that's why a lot of people turn around and they train with the IoT types of devices before they go on to some of the more expensive commercial devices.
So as far as some of the wireless technologies used for IoT and ICS, are there some crossover there?
Oh yeah, I mean, you can look at a lot of the research that was done put out by Travis Goodspeed and Mike Osman for about 8 years ago, all the way up to today, and they will take and plenty of people within this industries, and I'm just calling out those names. There's a lot of other security researchers that have done this. They go out and they find the technologies that are cheaper, the technologies that are easier to gain access to, that might not have some of the security controls that are put in there because they're more of a consumer product, and those security considerations, implementations potentially haven't been enforced, and they use those to develop their skills and understand the implementation and turn around to leverage that, whether it's tools that they've written or an understanding of the capabilities to assess those technologies within the ICS environment.
Yeah, it's kind of interesting also thinking about some of the IoT stuff. I'm sure with ICS, you have to be more careful with the products you use, because I've heard of some of the products that came out several years ago that had hard-coded usernames and passwords, or either no security in the devices. So I'm sure that's really a concern when it comes to like an ICS environment.
And yes, that's a part of the concern, is that vendors were not up to speed with the risks around those items. And the biggest concern is that those older devices are still implemented and working within the OT and ICS space. In other words, somebody's purchased something, maybe 5 years ago, they've already deployed it, and the process is running, and they can't shut it down. It either costs too much, or it's a safety hazard, or if they did, they'd have to recertify all of those things, especially after an update. All of that can be really expensive, and so it's part of the concern of why these devices are in there. The organizations don't want to, will accept risk until it gets too high, and they need to make modifications because of the safety and the expense.
Yeah, kind of while we're on the same subject of comparing and contrasting the two technologies, I know like IoT uses like Zigbee, Bluetooth, and Wi-Fi. What are some of the wireless protocols and technologies that ICS uses?
They're the same. They're the same, and the reason why we'll find Bluetooth and some of those other wireless technologies within an OT environment or OT ICS environment is because of safety. They want to have that standoff distance between equipment. If you can imagine walking through a plant, if you've ever done that, you've probably seen the yellow lines, the red lines that are a safety path. That's where people need to stay. More than likely, you have to have some type of eye protection within that area, but you might not have to have hearing protection or a helmet. But as soon as you step over that line, you have to have that safety equipment. That means that there's increased risk to the workers, And if you can get them to stand within those yellow lines, a safe distance from whatever those components are, that is a huge risk reduction. Therefore, they move to some of these technologies, the wireless technologies that are associated with that to improve that situation. There are industrial wireless solutions. There's wireless HART, there's ISA 100 that are implemented as well. And those are kind of depend on the industries, but certainly they can, the process engineers and the people that are coming up with the requirements for a process, they'll select whatever technologies are recommended by their vendors and by the integrators to help with the, access to information about the process, but also improve the safety. Does that answer your question, Phil?
Yes. And I know in class we touched on some RF stuff. So how common do you see radio frequency?
It really depends on the industry, and that's the great thing about this type of work is it's really exciting because you can go into one organization and they've solved their process in one manner, and then you go to another plant within the same organization doing the same exact thing, but because of when they deployed it, when they purchased the equipment, and when they integrated everything, it's a completely different setup. So you might have wireless in one process, but not in the other. And same with different organizations. And that's what's really exciting about this field is that diversity. Of course, it's kind of frustrating too, because you secure one thing in one area, and then all of a sudden you turn around and you're like, oh, but you've got so many of these other things we've got to address. And that's why it's difficult for security teams to get ahead of these things, is because of those differences, also the legacy implementations. But there's ways to get around that. We're organizing that, and really being organized is the key way to get around that.
So do they ever run into much of a issue with like shadow IT, or I guess in that case shadow OT, where people have implemented things to kind of as workarounds and introduce security risks? Do you see that much?
So shadow IT is really just somebody trying to do their job better or do their job safer. So when we do see these things that are or can potentially consider rogue, whether they're rogue connections or the rogue devices, whether it's a network device or a wireless device. And when you see it, I mean, as soon as we see it, and coming from the corporate environment, you instantly think, okay, that's a violation. We have to get it out of here and shut it down. Well, you can't be shutting these things down, because that might be serving a purpose and it's just not documented. Only a few people know about it. There might be a requirement for it, or they might have made something safer. And so, jumping to conclusions is not good within this environment. Definitely asking questions, finding out who implemented that, whether it's the process engineer or whether it's the operators within that environment or the field technicians. There's probably a purpose. Now, helping them understand the job of information security teams within these areas is to understand what's going on, and then help them understand how to do it safer, how to do it more securely, to ensure the integrity and resiliency of the process, rather than just shutting things down.
Since we're on that topic mentioning OT, I don't think we defined that. Could you define OT, what OT is, to our audience?
Yes, and operational technologies, it's the same thing as ICS. I'm starting to see the use of that kind of interchangeably, and I've heard people prefer the operational technologies over the industrial control systems. That's why I kind of go back and forth a little bit, because terminology in this field is one of the challenging areas. We have a part of the problem is, some of the protocols and technologies that are implemented are named similarly to completely different technologies within the corporate network. And so understanding that when you're talking with somebody, when you're communicating issues and ideas and or thoughts, understanding which one you're talking about, and clarifying with the teams, okay, I'm referring to this, it is pretty important. but from an OT and ICS standpoint, I'm starting to see that used interchangeably, and I try to include both in my speech so people understand and can make that correlation depending on what they're using within their organization.
Yeah, thanks for that clarification. It's definitely a mindset change going from IT to OT, because you wonder, why aren't you running the latest patches? Why aren't you updating this? And just think it's negligence on their part. But when it's actually, you can break stuff, and so you see the big difference. So it's a mindset switch. I know coming to work, my current employer, in their factories, we hear about stuff being so far behind, still running, older versions of the operating system and that. So it's kind of a different mindset, and definitely one you have to adapt to coming from areas outside of that, because in IT, shadow IT is a bad thing, and you shut down whatever is in place and there's no implications. So I can see where OT environment, you could cause harm or production issues if you just disable some shadow IT configurations. So it's very, very interesting.
And I think we need to clarify the difference between shadow IT and some of the vulnerability topics, or yeah, that topic. We need to clarify the difference. Okay, for me, shadow IT is something that the teams have implemented to achieve a goal and or perform an action. Okay, and whether it's authorized or not authorized, whether it's a good idea or not, that would be shadow IT to me. When we're talking about vulnerabilities, when we're talking about the methods for implementing and not upgrading operating systems, not upgrading endpoint devices, that's completely different. And that is all around requirements for the process. There are definitely good, I was going to say might, but I can't even say that. There are good reasons not to update processes, whether they're vulnerable or not. So when I'm saying update, I'm meaning from the endpoints, which are the controllers, to the master servers, which are going to be your Windows and Linux operating systems. Not updating those are going to be leadership choices, and we need to understand that within these environments. We need to understand how to manage that risk and reduce that risk without making modifications to the systems, because those updates can have serious consequences, meaning you update a system and you apply a patch, and then all of a sudden it doesn't work, it doesn't communicate anymore, it required some service that got disabled, or by making a change to the system, you have to reassess everything. And by assess, I mean like go through a checklist, the site acceptance testing checklist, and revalidate that everything's working. Actually, in some cases, actually recertifying, meaning that you have to pay a third party to come in and check every single thing to recertify that whole process. And that can be extremely expensive. So most organizations, what they're doing to manage those vulnerabilities is come up with some compensated controls. And that's really where a lot of organizations need to understand. They need to have vision into these environments. They need to know what's being passed across their networks and what's being communicated between master servers and controllers and on down. And that's how they're going to identify, when people are trying to leverage these vulnerabilities against them, and hopefully address it. In some cases, you might be able to do some prevention, but even prevention gets really tricky, because if you're preventing, you might prevent bad behavior, good behavior as well as bad behavior, and that could have a negative impact on the process and create a safety issue. So hopefully that clarification makes sense.
Yeah, makes total sense. Just coming from the IT world, shadow IT is usually a bad thing. But as you're talking about the different types of controls you have to put in place to secure those items, because they can't always be patched. So I guess in this case, this is where proper network segmentation would probably come in helpful.
It's very important. It's very important to plan those out. It's certainly an area that a organization can see a lot of benefit in by looking at their network segmentation and then network isolation. I have an example from our distillery. We had when we're walking through, we're looking at the distillery, and sure enough, one of their systems that was checking labels was a Windows XP system. And we looked at that and just kind of smiled at our escort He goes, yes, but we've isolated that completely. In other words, they could not update that system for two reasons. Number one, it was the only system that they knew that, that they'd purchased it and it was working well. Also, the organization had gone out of business, and so nobody was making updates to it. They still needed it, and so they weren't going to touch it. And their compensating control was not to take it offline, it was to isolate it from everything else. And that's the approach that most organizations can use to start things, is look at their network implementations, see if there are updates to how things are communicating, and improve that. Those changes might still require some recertification, so we have to take it as it is. But for those that can make those modifications, I think that's one of the biggest first improvements that they can do. It's easier because you're not you're just modifying the routes, improving the routes, and you're not having you're not changing things that are associated with the actual process. And by that I mean the controllers, the field devices that are managing the process. Certainly all of this needs to be tested. It needs to be planned out carefully. We need to have rollbacks and so forth, but it's the first step in my mind.
So is there really much of a problem with like ransomware in OT environments?
Well, that's the thing, is that the criminals are, whether you're talking about criminal organizations, nation states, they're identifying that this is an environment that is beneficial for them. Certainly everything started with critical infrastructure, but when organizations start turning to making money and things that can help where they can easily achieve their goals, these types of environments are rich with vulnerabilities, and so getting access to them and taking control of that is certainly one of the things that they want to do. We are starting to see ransomware type infections that are OT ICS specific. In other words, they're shutting down processes that are associated with vendors that control the endpoints, whether it's controllers or the field devices, those management softwares that are on Windows systems. We're seeing those shut down. But certainly any type of ransomware within these environments is a concern when we're talking about project files, when we're talking about network documentation. All of those things are just typical of normal ransomware. And so that would definitely need to be a consideration, understanding and having a process to address ransomware within these environments from an incident response standpoint, backups, how you're going to respond to it, and who's responsible for which actions. Organizations should be talking about that. They should be having their tabletop sessions, like how will we manage this if this happens within our control networks, because it's very important. Unfortunately, a lot of organizations are going to start seeing this.
Seems like USB drives could be could be problematic in those type of environments too, making sure the drives are clean.
And certainly that's a part of, there are a lot of vectors that malware can get into these. Certainly organizations, depending on their implementation and the maturity of their security program, they need to be considering external media and ways to manage that. There are solutions that it's because of different some of the older attacks that employed this as a method to get within the control networks. It's definitely a concern, but I don't know necessarily that that managing USBs and how they are leveraged within the control network, I don't necessarily know that that's the first step that they want to do. It really depends on the maturity of the program.
Very interesting. Next slide. So as I mentioned earlier, kind of my first exposure to ICS related stuff was working for an energy company, and the SCADA networks and just seeing some of the devices that manage some of the gas systems was my first exposure and first time hearing of that, and that was back like in 2000. So how is SCADA different than other applications of ICS?
So penetration testing within these environments is a bit different, and most organizations, they need a security assessment. They don't need a pen test. So are we talking about SCADA, or are we talking about pen test differences?
I kind of got ahead of myself. Sorry about that. So yeah, we're talking about when the difference between pen testing.
Okay, yeah, and that's what I thought. So yeah, the thing I like to tell people is that, and remind people, is that, you know, if you don't have a good security program and you haven't addressed a lot of the concepts, you know, whether it's low-hanging fruit or have just secured the environment, you don't necessarily need a pen test, in my mind. You know, unless you need to prove that something really bad can happen. And you know, I've seen instances of that, like, okay, prove it, show me that I need to do this. You know, show me that you can get access to this area, or gain access to these files. In that case, okay, fine, we need a penetration test. But in most cases, most organizations, particularly the ones that are not critical infrastructure, they need an understanding of the maturity of their program right now within that within the control network, so they can make those quick strides and quick improvements. In other words, paying for a penetration test, you know, the cost around that might not be the best benefit to them. So I always recommend start with a security assessment, ensure that that's not what you need. And then if they definitely need a penetration test, if they've got a mature program, then move to the penetration test to understand some of the holes in their implementation, some of the gaps in the responses, and so forth. But from when we're talking about like the actual methodology and implementation of a security assessment or even a penetration test, what I like to point out is that most of the core technologies are present. In other words, the technologies that we're used to in the corporate environments, whether it's databases, web servers, Windows operating systems, Linux operating systems, networking, all of those things are going to be in the control network. They're going to be in our OT environments. We're just going to have some additional technologies that we'll need to understand, but also we need to take into consideration when we're communicating with them. And that's a part of the problem, is that a lot of the legacy devices, they don't handle some of the tools very well. In other words, they weren't considered, they're not very robust in their management of network traffic. They will choke when they see certain types of packets, and they'll actually go down. They'll just hang on them. I've actually heard about devices that people have sent a packet to, and the device ran for for a while, and it was operating just fine. But when they rebooted it or it restarted at a certain period, it couldn't come back up because the packet had corrupted a part of its memory and a part of its firmware. It had overwritten a section of of the device that it required when it was booting up. So all of these things can happen. We have to be really careful when we're within these environments. So what I always recommend is that the people that are coming in to do the testing, or the ICS security team, the information security team that's helping with the OT environment, I always recommend that they go talk to the people that are associated with the process. What is the state of the process? What are you doing? Why did you deploy these things this way? Do you already have compensating controls for these vulnerabilities that we need to assess? And that is how you should approach it. We need to slow down, understand the process, rather than being like, operating like we do within a business environment, which is typically for a pen test. You get access, you get kind of an understanding of what the ground rules are, and then you just go do your testing. We can't test like that within this environment. Within these environments, we have to slow down a lot.
Yeah, so what are some of the risks that we wouldn't see in typical pen test and testing an ICS environment?
Well, I mean, the obvious risk is that you have a negative impact on the process, and that's going to lead to consequences. And it's whether it's bringing systems offline and something can't communicate, and that initiates the shutdown, or you write an accidentally write a value to a location that the process uses, and that causes those devices to act a certain way, and that has a negative impact on the process. The ultimate worst thing that can happen is some type of safety issue, whether it's with people or whether it's with the environment, and that's the worst case scenario.
Very interesting. That's one of the things you just normally don't think about. Some people that are kind of new to it know about the risk of injury or production. You could lose money, but one of the things that I really think about, you mentioned it here, and then you also had mentioned in class, is the environmental perspective. So some kind of toxic chemicals get dumped in the environment, that's not a good thing.
Right, and as much as as resilient as these processes can be, the fact that those risks are already there should take precedence. And because you might not do anything, but what happens if it does? What happens, if you take something down, if you take a controller down or an endpoint down or a master server down, what happens to that process? What happens to that environment? It might not hurt anybody, but they might have to shut everything down, and we're talking about anywhere from a day to weeks of being offline. And while that is certainly that's a risk, taking things down within a business environment is a risk. Usually they're a little bit more resilient in their recovery, and it's not necessarily the same within the OT environments.
Next slide, please. Yeah, from working in as a sysadmin for a energy company, SCADA was the first thing I heard of before I ever heard the term ICS. So how is SCADA different from other applications of ICS?
Well, SCADA stands for Supervisory Control and Data Acquisition. And what this is gathering information at a central point so that people can make decisions. Usually when we're talking about SCADA, we're talking about regional SCADA, especially when we're talking about utilities. In the United States, we have a lot of utilities within a specific area, and they need to make decisions. Some utilities do generation, some of them don't. And the example that I like to use is one of the regions within the United States goes from Louisiana all the way up to Canada. If a whole bunch of people turn their air conditioners on in Louisiana, it's getting hot, but they're not generating any electricity around that area, then they have to communicate with the dams in Canada to say, hey, please increase your generation. We have an increased load down here. And all of that information, information about usage, about generation, and exchange of data associated with selling and so forth, that's all collected in a central point, a SCADA control center, and managed by third parties. So you're going to have a lot of information that's coming in from a lot of different organizations and decisions being made. So that would be an example of regional SCADA. There is plant SCADA, and this is where the terminology gets a little strange, because one organization might call it SCADA, another organization might call it a digital control system, a DCS. And it really depends on how that organization is referring to it, how their vendor or integrator is referring to it. And so when you come into those organizations, you need to understand the terminology difference, the implementation, and what they're trying to accomplish. Because most organizations, they'll have multiple plants throughout the world, but they won't necessarily manage all of those plants across those regions. Each plant will operate by itself, but there still might be SCADA named technologies within that plant.
Very interesting. Kind of reminds me of networks, how you have your wide area networks, your metropolitan networks, campus area networks, LANs. So it kind of makes me think of those ways of the SCADA networks.
And yes, and understanding how they're using terms, understanding how they're actually implementing technologies, it goes a long way to understanding the requirements, understanding the approach, why they made certain decisions for communications, interconnectivity, and so forth.
Next slide. So since there is some difference in some minor differences in technology between ICS, OT environments compared to traditional environments, what are some of the common mistakes when pen testing ICS that you see?
I'd say the two biggest mistakes, the first one is not considering consequences, not realizing that when you're coming into these environments, that the actions that you take within these networks could lead to consequences. The worst case scenario is, you have a negative impact on the process, on the equipment, you're bringing things down. And that would be the ultimate worst case scenario. That's a little bit harder to do. The processes try to protect themselves, and hopefully that happens. I would say that, and so not understanding that leads people to moving too fast, trying to use their tools in a manner that they're used to in the corporate environments, which can't be done within the control networks. So not understanding your tools, using them incorrectly, not realizing you have consequences leads to that. The other thing is not actually understanding the process itself. And this is one of the biggest things, the biggest requests that I have from people when I'm talking about educating information security professionals that are coming into the OT ICS arena. They say, when you get there, sit down with the OT teams, ask them about the process, have them show you the process, walk you through what they're doing and why they're doing it. Also, every time I do this, I'm asking questions about, what were the requirements around this that led to these decisions? Because when you hear about that and you understand the choices that they made, you say, yeah, absolutely, they need this technology. It's insecure because of this reason, whether it's a choice because of latency within within that network, or it's because it's legacy that can't be upgraded. There's a reason around all of this. They've probably talked about this before. So understanding that and then doing your testing and helping to improve the security around those requirements, that's what needs to be done. And that's probably the biggest mistake that I see as well.
Next slide. So there's a lot of other areas that people can get into pen testing. There's lots of resources, pretty easy to find out by doing a quick Google search and looking on like SANS website and some other websites that offer education. So how does someone go about learning ICS pen testing?
And certainly that's what you just described as far as finding organizations that provide training around this. Certainly SANS is one of those. So we have the ICS 410, which is the ICS SCADA Security Essentials, to help people understand the different concepts within there. That would be one way. We also have the hosted class, which is the assessing and exploiting control systems. As I mentioned, it's more about the methodologies for how to approach penetration testing and security assessments on these type of technologies, all the way down to the hardware level. So that would be training methods. But of course, we touched upon getting an understanding of these technologies, especially the hardware, by doing your own training. It's difficult to buy industrial control systems. So, for instance, I just luckily enough, I'm involved with the ICS Village, and so I spoke with a few of the people that are associated with that, and they purchased me some very expensive radios that go into processes. And so the radio setups that I have right now, I'm willing to bet that this costs over $4,000 to do. I couldn't do this on my own. Certainly I have to make sure I get the research back out into the community, and I'm working on that. But that's difficult for anybody to purchase. There are other resources out there that are a little bit cheaper. There's a Velocio PLC, which is kind of a self-contained program logic controller. That's the one that we used and you picked up in the assessing and exploiting class. It's anywhere from $50 to $70 or $50 to $80 for their basic level ones, and that will help you understand how controllers work, how they're programmed, and so forth. Actually, it provides Modbus capabilities, so you can interact with Modbus for once you program it, you can manage that device, whether it's over serial or whether it's over Modbus. So those would be some things that I would get into. There's a Click PLC, which is relatively cheap. I think it's about $120, and that's another program logic controller. But that's just a program logic controller. That's not power. That's not a board to mount it on. That's not the other communication requirements. And one of the most expensive things associated with all of this is the software that's involved. Some of the hardware is cheap compared to the management and server technologies that are used to operate these devices. So falling back to some of the implementations that are, when the microcontrollers and storage devices are implemented in commercial technologies, whether it's toys or whether it's some type of IoT device, that's definitely an approach. There's a lot of tutorials out there. A lot of people have done this, and so following in their footsteps is a good way to do it.
Yeah, it was interesting taking your class. It really got me interested in the hardware side of things, which I really hadn't done much with, but was very interesting. It got me interested.
Yes.
That's kind of neat. The other technologies in that course, like the RF stuff I hadn't been exposed to, that was really cool as well.
Yes, I point out in class that Jason Larson has a presentation. Gosh, it's 14 days to compromise, I think it's called. It's it's up on S4's YouTube channel, and he talks about his approach at going after some of the devices in here. So reversing, collecting information between the master server or the management software and the serial to Ethernet interfaces. You can pick up some of these devices on eBay and do some of the similar testing, kind of following their footsteps. And that's a viable way of learning these types of technologies and reversing and so forth.
Very cool. Next slide. So we covered some really interesting topics during this with Don sharing this information with us. So we're going to kind of go over some of the key takeaways for ICS best practices. Understand technology differences. OT ICS environments have similar technologies with different goals, while OT has specific technologies.
Absolutely. The technologies in the corporate environment, you're going to find those in the ICS environments. There's actually just going to be additions to it, and so understanding why they selected those, what were the requirements for the process, and realizing that there's going to be insecure technologies, whether it's unencrypted communications or whether it's the software hasn't been updated or the operating systems haven't been patched. It's all for a reason, and understanding those differences and being open to that is certainly important to moving into this arena.
Assess security needs first. Start with passive info gathering and escalate slowly and carefully to active.
And this is going back to the penetration testing methodology that we're talking about, Phil. And that's we have to even if we're doing a pen test, but certainly these would be the steps for just doing a security assessment. Want to start passive. We want to gather as much information from the team as we can first, then do potentially net flow and PCAP information gathering, which is in my mind some active, because that's active testing because you're interacting with a few of the devices that are in there. But then when we're talking about real active things like scanning for devices, you definitely need to be slow and careful and ensure that you're communicating in the manner that they expect to be communicated with.
Test your skill level. If you do not understand the physical impact on an action on the process, do not try to modify a process.
Yeah, I came up with this saying, test your skill level, because I'll fully admit it, I don't know the physics around a lot of the environments that I go into. I'm actually talking to the process engineers around what they're doing. I'm talking to the operators. When I went to the distillery, I was actually talking with master distillers, and it was pretty awesome. And I'd sit there and I'd ask them what was the worst thing that can happen to these processes? What are you concerned about, and so forth. Realizing that I don't know the physics behind some of the actual bad parts of the attack. There are people that are out there that do know that, and if that needs to be a part of the testing and understanding, I would bring them on as expertise around that. Jason Larson, as I mentioned, being one of those. There are a handful of people that I'm aware of that can test to this. So test to your skill level, understanding what you're capable of and what your team's capable of, and then certainly look to experts to assist you.
Interact with OT teams. Try to understand the what and why about a process before making recommendations.
Yeah, and this goes back to sitting down with the team, creating those relationships between whether it's IT, IT security, and the OT team. Everybody should be sitting down. Everybody should be talking about the goals around securing the environment, and also goals around doing a security assessment and penetration test. Everybody should be on board. Everybody should be understanding what what the team's trying to accomplish, and agree to it, and that it's the appropriate thing. And when you do that, you're operating as a team, and you're going to ensure that the OT teams are more comfortable with those things occurring while the process is live.
Good stuff. Thanks, Don. Next slide.
Great, thanks for a great conversation, Phil and Don. At this point, I'd like to open it up to the audience. So if you have any questions, just go ahead and submit those in either the question or the chat panel, and Phil and Don will be able to answer those. Okay, I see several questions coming in here. First one is asking, is it possible to set up a home lab for ICS testing?
Well, I think it is. I mean, it can be expensive, if you're talking about actual equipment. And as I mentioned, the Click PLC, if you're wanting an actual PLC that might be deployed within a process, that is one way to go. But you will need to. There are more components to consider around that. We fall back to the Velocity PLC in the class because it provides that same type of functionality. It has structured function blocks to learn how developers are going to program some of the processes. You can do ladder logic with it as well. And if you open it up and try to communicate with the microcontrollers and other components that are on there, it's relatively cheap to replace if you accidentally brick it. But I would certainly fall back to looking at some of the technologies that other people have pointed out, and to help them understand the concepts and so forth.
Okay, great. Another question coming in. In the ICS world, do you do static code analysis to scan through the code for insecure coding?
I've seen it done, and I've seen it done well. I've actually, and this was more back in the 2012 region, so I haven't done it recently, but absolutely, we're doing static code analysis to assist their teams when to understand vulnerabilities within that. And I know of at least one case where remotely exploitable vulnerabilities were discovered in source code analysis, and then they were actually asked to turn around and prove the implementation via injecting packets wirelessly at the endpoint, and they did indeed prove that they could take down that. It was a denial of service attack at that point. They could take down that endpoint. So I am seeing that out there, source code analysis. It is an important part of the process. And what you're typically going to find is that's at the vendor level. But a lot of these organizations do their own programming of PLCs, write their own code. They have development teams. And so hopefully they are doing some type of source code analysis as well. So you will see that potentially a part of assessments.
Great, thanks for that. We only have a couple more minutes left, so this will be the last question. In your opinion, which is tougher for pen testing, ICS or IoT?
For me, it's it's pretty. So pen testing. Remember the implementations that I talked about was the actual penetration testing for IoT is we're talking about more commercial solution or customer-based solutions in the home, and you're going to find the IoT stuff within your corporate environment. So I would say it's actually easier there, and then because you're in that corporate environment and you're not as restricted to the things that impact the endpoint as much as you are within the OT environment. So I definitely think it's more difficult to test to the OT environments and those technologies than IoT, but it really depends on what we're talking about. We would have to assess the risk and implementation and where it's being deployed. So hopefully that answers your question.
So here's some resources if you're interested in more information. This first resource here is Don's company, and he's got a blog and some good information on there you could check out. Controlthings.io is a Linux distribution for testing ICS. And then we have the SANS blog for ICS. Dragos is another good resource. They're a company that specializes in industrial controls. So they've got a blog out there, as Don mentioned through this conversation, that SANS ICS 410 is a good course to start with out there, and then the SANS ICS YouTube channel.
And one thing that that we didn't mention on here, and certainly you can find it through the SANS site, SANS has a new course, the ICS 612 class, which is actually designed to implement industrial control systems, deploying PLCs, managing a process, learning those technologies and how to configure them correctly and securely. Just heard amazing feedback about that class. Everybody's really happy about it, and highly recommend it.
Well, thanks, Don, for joining me today. It's been great discussing ICS with you.
I really appreciate the opportunity, sir. Thank you for having me on board, and thank you, Kim.
Great, thanks so much, Phil. Thanks, Don, for a really engaging and interesting conversation. And thank you everyone in our audience for joining us today. We will be sending a recorded version of the event afterwards, and do be on the lookout for the next episode in Pentester Confessions. Thanks everyone again, and have a great day.